Hello, this is the AP Calculus BC problem number 19. This problem we need to figure out which of the following statements about the summation from n equals 1 to infinity of minus 1 to the n times n over n squared plus 1 is true. Let's work our way through it. The series can be shown to diverge by comparison to the summation from n equals 1 to infinity of 1 over n. So that summation over there is the divergent harmonic series. But if we try and do the comparison to these, if we compare that to 1 over n, we can see that this over here is going to be greater. And now if we say that the greater one is divergent, then that doesn't mean that the smaller one per se is divergent itself. It could be convergent because it's smaller. And then also, it's also messing up over here about this minus 1 to the n. It doesn't take into account that. So it does not mean in any way that it will diverge because of that. So A is wrong. Now we go on to B. The series can be shown to diverge by limit comparison with that same summation. So again, that is the divergent harmonic series. If we take the limit from n as n goes to infinity divided by 1 over n, we will get the limit as n goes to infinity of n squared over n squared plus 1. And those n squareds are going to be the only thing that matters, so it's going to be infinity over infinity, which equals 1. So the limit comparison test shows that this series would diverge, but it can't be concluded but you can't conclude that because we're dealing with this alternating series. And just because its absolute value of the series diverges does not mean that it itself will diverge. So now we move on to C. So it says this series can be shown to converge by comparison with 1 over n squared. So this series over here is convergent, and it has it's a p-series with p equals 2, which is greater than 1. But if we try and do the comparison to it, 1 over n squared and n over n squared plus 1, you can see that this is going to be bigger as long as n is greater than 1. And with the summation, we really only care about values extremely high. So if we say that the smaller one converges, then the larger one could diverge because it's larger. So the inequality really just goes the wrong way to use the comparison to show that the summation of this would converge. Okay, so now we move on to D. The series can be shown to converge by the alternating series test. So the alternating series test has 3 parts. First part, it says the series needs to be alternating, which as we look at it, it is. And the second thing it says is that the absolute value of the series limit as it goes to infinity must be 0. So the limit as n goes to infinity of n over n squared plus 1 needs to go to 0. And let's see if that's true. So if we get an infinity over an infinity squared, that's going to be like 1 over infinity, which is 0. So the second part is true. And the third thing that the alternating series test says is that the function is decreasing. So if we say like a of n equals n over n squared plus 1, then a of n plus 1 equals n plus 1 over n plus 1 squared plus 1. And this must be smaller than this. And so we need to say that it is less than this over here. And you can simplify this, and you can get 1 is less than n squared plus n, which will be true for all n greater than or equal to 1. So we see that D is in fact the correct answer. Thank you much for watching, and goodbye.